Hello everybody, my name is Jim Pingle and welcome to our March 2018 Hangout. This month we're going to talk about monitoring pfSense 2.4 with SNMP. Let's see, what we'll go over in this Hangout, project news as always. We'll talk about what SNMP is, what an MIB is, a little bit about network monitoring systems. I'll talk about SNMP security concerns, so SNMP support in pfSense, comparing our built-in BSNMPD versus the Net-SNMP package, how to configure BSNMPD, and then a few different things about Net-SNMP configuration because there's a lot more to that. All right, first up, we got our project news. Our 2.4.3 release is out. It just came out yesterday, so if you haven't updated, you want to go ahead and do that. Has security and bug fixes and a few new features. The biggest ones people were waiting for were the kernel PTI mitigations for Meltdown and the IBRS mitigation for Spectre v2. Which that one does require a microcode update, but there for a CPU, but there is also a microcode updater in there. So hopefully that'll take care of everything. But again, they weren't really relevant for how pfSense is used as an appliance, but still good to have those fixes in there for a good peace of mind. For more details about the release, you can check out the blog post link there and also the change log that's up on the doc wiki. Our XG7100 1U device that I mentioned last month, it will be shipping in approximately 2 weeks. So everything's in place in the 2.4.3 release for that, and we're just waiting on that to get everything else ready to go. Acme v2 is live, so if you were using the Let's Encrypt with the Acme package, you can now use it to generate wildcard certificates with the new Acme v2 production servers. That does require a DNS update method. If you're curious about doing that, we do have some information on the forum and on the pfSense subreddit, and the documentation for that will be coming pretty soon. Also, Hangouts older than 12 months will now appear on the Netgate YouTube channel. So Hangouts like we're doing today, the older ones, the more than a year old, they'll start showing up on the YouTube channel for people that don't have access to gold content. Okay, well, let's get right into this then. So first up, what is SNMP? It stands for Simple Network Management Protocol. It's used to retrieve and in some cases set device data for network management. So, usually use it for things like interface traffic monitoring, monitoring errors, CPU usage, memory usage, disk usage, basically just monitoring the general activity, health, and other statistics about the device in general. Normally, that'd be done by a network monitoring system type thing. It's a stateless protocol, has no concept of sessions, so every query and reply is handled in an isolated manner. So an SNMP client will ask the server for data from a specific OID, and then the server will respond, but there's no like login persistent mechanism session type thing. It's all just instantaneous. Common ports it runs on, UDP 161. There's also UDP 162 for traps. We're not going to get into traps today. We don't really have the time for it, but that's something else to look out for. There's also TCP with port 10161 for TLS or encrypted TLS communications. There's UDP 10161 for DTLS or datagram TLS. In general, UDP is the best to use. There's less overhead, a little bit more efficient for bulk data transfer like that. But TCP can be more reliable, especially if you're trying to use it for TLS. SNMP support for TLS is kind of hit and miss as it is, and DTLS is even more hit and miss than regular TLS. So mainly in terms of client support. Okay, so in SNMP, the data is organized into a hierarchy of numeric object identifiers or OIDs. So you might have like a table of interface information. It's at like this one shows .136.121.22.11, and under like that. That can be kind of hard to interpret, which is why we'll talk about MIBs here in a minute. There are 3 common versions of SNMP. First up is SNMP v1, which pretty much everything that's ever supported SNMP will support in some way, but it's the slowest and weakest of them all. Very poor security, community-based authentication, which is really just a username and password just in one value, and it's sent in the clear. No encryption, no protection, nothing. But it is very widely supported, although pretty much everything out there now should support at least SNMP v2c, which followed on beyond that. V2 was supposed to have authentication, all kinds of other fancy stuff, but it was deemed too complex, not feasible enough. So they took some improvements from SNMP v2 and rolled back just to the community authentication of SNMP v1. So we got v2c, which is v2 with community authentication. So it still has the poor security, but it does have some improved speed and efficiency improvements versus v1. The protocols aren't compatible, but most clients out there will do 2c, so you shouldn't have to force anything to v1 unless you're talking to something very, very old. So because v2c still uses community-based authentication, you still have to be careful. Everything's set in the clear. Just that one value, not really even a username and password, just a password basically. But there are some implementations of v2c out there. I think some Cisco devices have MD5 hashing of the community, but that's very hit and miss. I don't think Net-SNMP supports that, so I mean, obviously it's not going to work on pfSense, but there are some things out there that do, so just keep it in mind. But it's still not great. But then along comes SNMP v3, which builds upon v2c and adds security onto it. So it verifies the identity of its peers to control access. So you can do authentication by user-based security, like the user security model or USM. There's transport-based security, which is TSM or transport security model. And TSM uses TLS or certificates. It can do privacy via encrypted communications. It can do in USM mode. There's some basic privacy security encryption it can do there, or in TLS, with TSM it uses TLS encryption, like many other things do. It also has integrity checking to ensure packets have not been modified along the way. So much more secure, not just in controlling access, but also in controlling the protecting the data as it goes through. So you get authentication, you get integrity checking, you get a lot more security. So I mentioned MIBs a moment ago, and MIB is a management information base. It's a data model definition for SNMP. So if you open up, they're all text files. If you open up in a text editor or using like an MIB browser or something, you'll see all sorts of different names listed and data types, and basically it defines everything that a certain module or section of code in SNMP will offer in terms of system data. And the MIB allows the SNMP software to translate those names to numeric OIDs and back and forth. So it's much more user-friendly, like DNS. So what's easier to remember, the big long string of numbers, or you can do like a namespace thing with an MIB and then a specific identifier, or in many cases, because the identifiers are generally unique, you can just shorten that just to the name of the data itself, just LA error flag in that case. So if I have some time at the end, I'm going to go over an example of how an MIB helps the software to translate the names to an OID. I'll break it down and go point by point. If not, I'll get that put up with the slide, with the slides and the video when it goes into the archive next week, so you can look at it then. The MIBs for pfSense and FreeBSD can be found in user share SNMP MIBs, and those can be added to your network monitoring system as needed. Like you can just grab the files from there, the text files, and then load them up into your network management system or whatever SNMP software you are using. Or if you're going from FreeBSD, I'll try to show an example of how that works in a minute too. There are some PF-specific pieces, but they do only work with BSNMPD at this time, and I'll go into a little bit more detail of that in a moment. Okay, also I mentioned network monitoring systems a moment ago, and those are a network monitoring system, or NMS. It's a piece of software. It collects data from devices and performs actions on that data. So basically you would have a network monitoring system, and it would be pulling data from dozens or hundreds of different devices out there on your network, whether they're firewalls, switches, computers, whatever. And it would be handling a lot of the stuff, and it would be retrieving this data. It could be SNMP, it could be an agent supported by that particular NMS. It varies based on what they can do. But at their heart, most of them will support at least things like graphing and alerting and notifications, and among others. So, it might alert you to certain things like interface errors, or if your state table's over a certain size, things like that. There's a lot of different NMS software out there, some free and some commercial. There's a big long list I've listed there, and there's even more on Wikipedia. There's a big comparison table. Like all but maybe 2 or 3 support SNMP in some way. So it's something you can leverage. I mean, even if there's an agent or something, there may be some information you can get from SNMP that you can't from the agent, or it's easier to get it from SNMP, or it's a good complement. So it doesn't hurt to have access to. If you're trying to pick something NMS-wise, you want to make sure you look into it and see what it supports. Ideally, you'd want to find something that supports SNMP v3 if you can. SNMP v3 with TLS would be great, but not a lot of things support that yet. If you can't do the TSM TLS stuff, you can at least hopefully do SNMP v3 with user auth, and hopefully with privacy at that. So because SNMP is fetching all of this data, there's a huge amount of data it can expose about your device. And so it can be very dangerous. It's not something you want anybody to be able to intercept. It's not something you want somebody to access in an unauthorized way. If somebody could pull your device, whether without your knowledge, they could get a ton of information about it, maybe find a way in. If nothing else, they might be able to find some sort of information there you don't want them to have. So you never want to run SNMP over the internet, or any untrusted network for that matter. So V1 and V2C both transmit the community and other data in the clear. So you definitely don't want to run those over the internet. Anything anybody could sniff in between, they could see all of that. SNMP v3 is a little bit better because it can encrypt the transport, but the service itself is still kind of weak. Somebody could brute force USM. It's really not the best practice to expose it to the internet if you can help it at all. But if you have to, then at least do SNMP v3 and maybe filter it so that only your NMS can reach your firewall. Ideally, though, you want to run it over a VPN or some other kind of private link or a local management network. When it comes to protecting this, you do want to use multiple layers and tactics as much as you can. Firewall rules to control access to the daemon, make sure nobody can hit it that you don't want. Encrypt it over a transport like a VPN or TLS, or at least an isolated management network. Access controls in the SNMP daemon if they're available, which I'll show you how to do a lot of that in Net-SNMP. Use a complex and long community name if you're forced to use V1 or V2C. You don't want that to be something that could be easily guessed or brute forced. You want strong passwords and encryption keys for USM with SNMP v3, just so it couldn't be brute forced or guessed. And ideally, if you're doing TLS or TSM, it's pretty solid to start with, but you do want to make sure you use a pretty good strong certificate. Key length over at least 2048, and use SHA-256, not like the older SHA-1. Okay, so support for SNMP and pfSense, there's 2 different ways you can do it. You can use the built-in lightweight BSNMP daemon, or the more capable but heavier Net-SNMP package. BSNMPD can provide some PF-specific data that Net-SNMP doesn't have access to. But that data is not very widely used. The PF data you can get like state table size, some table information, alt queue information, packet processing stats, tons of stuff. And it's all listed there in the PF MIB on the file system if you want to dig through it. Or you can use SNMP walk and go through the whole hierarchy that's under the PF module there. There's the OID and then the MIB name equivalent there. You can run an SNMP walk against those and see what all's there. And ideally, if you have the MIB loaded into your SNMP client or NMS, it can actually show you the names of all those objects, and you don't just have to guess at what's what. But otherwise, if you're looking for non-PF things, standard Unix or FreeBSD system templates apply. There's usually, depending on your NMS, there's probably a template for either a standard Unix system or a standard UCD style system that would work. But again, varies a lot based on your software. There are some commonly requested items. People ask us all the time if we can do these via SNMP, and generally the answer is no, but there are ways around it, which I'll show you too with some extend commands. People ask all the time for like HA and CARP status, gateway status, VPN status, captive portal, and other pfSense specific stuff. None of that's available in SNMP out of the box, even with the package. But there are some things you can do with Net-SNMP. We don't have any of the fancy stuff built in just yet, but it's pretty easy to script things if you know what you need. But I'll get into that in a bit when I get to the Net-SNMP custom commands. One thing that you can't get by SNMP in any way is per IP address throughput. You can get interface throughput, but not broken down any further than that. If you need per address throughput, you can use NetFlow, and we did a hangout a while back on just general monitoring, bandwidth monitoring, and I covered NetFlow there. So if you're after that, you might want to go back in the archive and check that one out. Okay, so BSNMPD versus Net-SNMP, I'll show you, kind of give you the pros and cons of each of them, what they support, what they don't. BSNMPD is good because it's built in. Net-SNMP is available as an add-on package with on pfSense 2.4 and later. It's not available on 2.3. Let's see, the BSNMPD one, it's built in, very small, very light, consumes very little resources. So that's a plus, but it's not a huge deal generally because the SNMP daemon is not going to be using that much anyway. But it's still nice that it doesn't use too much. It's modular in that you can turn off certain modules if you know you don't need them, and it will save you a little bit of memory there as well. Downside though, it only supports SNMP v1 and v2c on pfSense. The daemon itself is supposed to be capable of v3, but we haven't got that going in our GUI. And not sure if we have any ETA on that or if we're just going to go with Net-SNMP in the future. Because it only does v1 and v2c, it only handles community-based authentication. There is no user authentication. It doesn't do any kind of transport encryption or integrity checking. It only supports IPv4 UDP, so you can't change that to TCP or use IPv6. You can change the port. Defaults to 161. That's pretty common, or that's the common SNMP port. So that's pretty standard, but you can customize that if you want. You can bind it to one or more interfaces or VIPs, but there's no way to execute custom commands in through SNMP in the pfSense GUI. I think some people had found some way to do that in BSNMPD, but it was kind of awkward to do, and we haven't yet try to come up with a GUI way to hook into that when it's so much easier to do in Net-SNMP. At the moment, BSNMPD should be fairly stable, but it has had stability issues on certain platforms in the past. Like up until recently, there was a problem on virtual machines, like I think it was ESX, where if, or I think it might have even been some real hardware where if there was a CD drive, but it didn't have any media in it, it would chew through 100% CPU in certain queries. There's also been queries that have been known to crash the daemon. So that's something to be aware of. Everything we know of, I'm pretty sure has been resolved. There might still be some out there though. So if you do want to run BSNMPD, consider using the service watchdog package to monitor the daemon and restart it if it crashes. All right, moving on to Net-SNMP. It is larger, consumes more memory and resources than BSNMPD, but it has a lot more features. Biggest one is that it supports SNMP v3 in addition to v1 and v2c. It also can do TCP and UDP. UDP is more efficient, but TCP, it's better from a reliability standpoint, so you can have some assurance that you're actually getting a good connection and that your packets will be retransmitted and not just lost. It does support both IPv4 and IPv6, so if you want to run SNMP over IPv6, that's the way to do it. You can do custom service and port bindings. You can have multiple ports and protocols at the same time. It does user-based authentication with privacy protection or encryption. It also does transport-based authentication with TLS and certificates. You can limit community access for v1 and v2c. So you can do like source address restrictions. You can set a base OID to restrict access to just a certain subset of SNMP data. So it's pretty flexible, a lot more flexible than BSNMPD with access controls. And you can also set a base OID for users as well. It also does SNMP over TLS over TCP. The package also does DTLS over UDP, but support for that in clients is kind of very, very hit and miss. I think I mentioned that already, but like I think even FreeBSD doesn't work right, even talking to itself. But I think Linux, last time I tested it, you could go from Linux to FreeBSD, but very hit and miss with DTLS. So, but TLS works everywhere. So if you have a choice for TLS versus DTLS, TLS or TCP TLS is most likely the best choice to use. You can also do custom shell commands. They can return data over SNMP via extend entries, which I'll talk about. You can generate and receive SNMP traps, but I'm not going to have time to go into SNMP traps today. I might do another hangout eventually over the advanced SNMP traps and sending and receiving traps and doing stuff like that. You can also set bulk request limits to prevent a denial of service situation from runaway queries. So let's talk about configuring BSNMPD here. It's just under services and SNMP. And first up, obviously, you can check enable to turn it on. The only things you absolutely have to set are the port and the community string. The polling port should probably be left at 161. You can change it if you want, but the default's generally the safest thing to do. The location and contact are free text fields, let you just identify the device. Like if your NMS is pulling a bunch of pulling SNMP from a bunch of different devices, it can help you identify things, especially if you have some kind of like if it has like host detection type thing where it will scan your network looking for devices. It'll help you pick out what this is. So you can fill in that location and contact, and I think it also automatically plugs in the host name in there too. But very straightforward. Community string, again, this one here is just a weak example. Public, you don't want to use that. Replace that with something longer and hopefully with some randomization in it. That way, it works a little bit more like a password, but just keep in mind it's still in the clear. Traps are optional there. They're supported by BSNMPD, but I'm not going to get into those today. And then next we have the modules. Every module you load here is going to consume a little bit more resources. So you do want to keep this list, kind of trimmed as much as you can, but really there's not much of a benefit to keeping it trimmed. So it's a bit of a trade-off. I think we check everything but regex by default, if I remember right. So not a huge deal to just leave it that way. But if you're looking to trim anything, here's what they all cover. The MIB2 module has networking information about your interfaces, the interface hardware IP addresses, amount of data transmitted and received. So that's a pretty important one for interface statistics. NetGraph has some additional interface information about NetGraph, which mostly is related to PPP and I think PPP and L2TP, that kind of stuff. Now that could be like your PPPoE server, an L2TP server. It could be like a 3G, 4G modem, that kind of stuff. PF has all the PF information I mentioned before, like state table info, alt queue, that kind of stuff. Host resources, which requires MIB2, has information about the host itself. You get like uptime, load average, process list, storage types and usage, system devices, and installed software list. There's a bunch of other stuff in there. There's also the UC Davis MIB or UCD, which will give you memory usage, disk usage, running programs, and a lot more. And then there's also the regex module, which we don't use at the moment. We don't actually have the rest of the GUI code in there for it, but it can create SNMP counters from logs and other text files. And lastly, down here, the interface binding section, you can see it's got a control. It's got all of your interfaces and your VIPs listed here. when it's set to all, and this part here is true for BSNMPD and for Net-SNMP. When it's set to all, because it's a UDP daemon, it will respond from the closest IP address to the destination, which might not match where it was sent. So you need to be careful when you're communicating with an NMS, because that little thing could trip up firewalls in between you or states in between you. You need to have it where it's if you have a situation like that, you need to be talking to the address on the firewall closest to the destination. So, for example, OpenVPN can kind of trip this up a bit. If you're talking to an NMS that's across an OpenVPN tunnel for you and your NMS queries the LAN address, the firewall might respond from the OpenVPN interface address because it's closer to the destination, which that can, like I said, can confuse things in between. You could confuse the NMS, could confuse anything. It might drop the reply, or it may never get the reply. So in those situations, and especially with IPsec as well, with IPsec, that reply would just never get to the destination because it wouldn't match a P2. It might actually go out of WAN or something. So you need to make sure that you set that binding to a local interface that can communicate across the VPN. Now, if your LAN or a management network interface or interface network was inside like your IPsec P2 or is routed in OpenVPN, you could bind the daemon to that interface and that interface alone. And then, when it is sent a query across the VPN, it can reply from the expected address and it can get back through the VPN. So that's something to watch out for no matter which one you're using. And again, you need to allow access to the daemon in your firewall rules, whether that's a local management interface over a VPN or however you're going to reach it. Obviously, I don't recommend you do it on WAN, but if you need to, then you could set up a firewall rule on WAN from a specific NMS source address to that, and hopefully you're using SNMPv3 with privacy. Okay, let's see. That's it for BSNMPD. That's really all there is to it. And you can hit that with like SNMP get or SNMP walk. Just tell it like version 2C and then your community name and then the host name, and you can look for some data from that. I was trying to see a good example for the PF data, but I can't remember what that was off the. Oh, I think I had it over here in that text file. What was I looking for? Here's one, just PF status running. Oh, because I didn't have the MIB dir loaded in there. I had it up here somewhere where I was hitting it a little bit ago, but let's see if I can't find it then. Can't find it. Come on. Yeah. There we go. I must have had the directory name wrong or something. But yeah, you can hit it using the MIB name and everything. It'll show you it's running. And that was just one part of one thing you can look at. Okay, so moving on over to Net-SNMP. If you're going to use Net-SNMP, the first thing you want to do is make sure that BSNMP is disabled. I mean, technically, if you're running them on different ports, you could leave both enabled, but I wouldn't do that if I were you. So next up after you disable that is to install the Net-SNMP package. So just go to System Package Manager, Available Packages tab, find it in the list, install it. Once you've got that installed, head on over to Services and, oh, sorry, wrong firewall there. Services, SNMP, Net-SNMP, and it'll land you here on the General tab. Now, when I was coding this package, one thing I paid attention to a lot was adding a ton of extra info. So there's a lot of information here in the interface that tries to explain everything that you need, but there is some even additional advanced information that will go further if you click the little I buttons you see. There's a lot of like command examples and configuration file examples and things that you can use for other clients as we go. So if you see an I, click it, and read the extra available stuff there. So obviously, first thing you want to do once you're on this page is to click Enable SNMPD, and then we need to set up our interface bindings. Now, by default, it just has one line that's listening on all interfaces on port 161, which is the default. If you go to add other entries, you want to leave at least one of them on UDP 161. Like here, I've got that one, the first one on UDP 161, then I have DTLS set up and then TLS set up, and those are both on port 10161, but obviously DTLS is UDP, TLS is TCP, so it's okay. They're on different ports. So these are the places it's going to listen for these requests. You really should have an IP address or a host name in here for binding. That's best, like I mentioned, is if you're hitting it over a VPN. I have these bound to all because in my testing and in my examples, I'm hitting them over my lab WAN, which it's all isolated, but not a great example to set up that way, but it's a lot simpler for a demo. But ideally, you want to have the binding addresses filled in. So in these other transports too, there's UDP for IPv4, there's UDP6 if you want to set up an IPv6 binding. Same, there's TCP and TCP, or TCP for IPv4 and TCP6 for IPv6, then DTLS and then DTLS, UDP, and TLS TCP. So you can have as many of these as you need. If you want to have one, UDP, TCP, UDP6, IPv, or TCP6, you could have one for every conceivable protocol or multiple of the same protocol on different ports. Whatever you need to do to accommodate your NMS or other SNMP local clients, that you can do. So very, very extremely flexible. And as before with BSNMPD, you want to make sure wherever you set these destinations up to be allowed, you want to allow those in firewall rules. So you need to make sure that not only you're binding to the right place, but also that clients can actually reach you. All right, next up is our identification section down here. The engine ID is a way to identify this particular instance of SNMP on this firewall. Most of the time, just leave that at firewall IPv4 address. You can also use IPv6 address or a MAC address, or you can enter an arbitrary string below here in the engine ID box. If you choose string, then you can enter one here and it will use this. If you have it set to like firewall address, it'll ignore this box. Underneath there, there's a spot for the CA certificate and server certificate. If you're going to use TLS, you need to make an appropriate certificate authority. If you're not going to use a certificate authority and your server certificate is self-signed on its own, then you can set self-signed in the CA box. Or if you're not going to use TLS at all, you can just leave it set to none. If you're for a server certificate, you want to leave it in there or pick it from that box or set it to none if you're not going to use TLS. The best practice for certificate authorities is to use a similar structure to OpenVPN. So, make a CA on pfSense, and then you need server and client certificates, and they're all signed by the same CA. That last bit isn't as critical because it does use client certificates. The client will be identified by the certificate fingerprint and the properties of the certificate. I don't think it actually validates it against the same CA because it doesn't actually ask for a client CA, but generally it's safer to do it that way anyway. Transport prefix, that field there, you don't have to worry about it, just leave it alone. If you know it's necessary and you know you're in Net-SNMP, you can add that if you need it, but I just leave it alone. Rate limits, again, something you probably just want to leave alone. These fields down here to set like your max bulk get repeats and max bulk get responses. Those would be a way to prevent a client from requesting too much data and performing essentially a denial of service. Either they could do some sort of reflected SNMP attack where they're sending a request to you and then you're sending it back to some other unintended target, or it could be a runaway NMS that's just performing tons of queries and chewing up your CPU. You can set these if you want, but you really need to be careful that you do not set them too low. Like you don't want to set them so low that your NMS can't get the data it needs. So you kind of might have to even go so far as to packet capture some requests from your NMS and look at the kind of volume and that it's doing, and set it a little bit higher than that. But it's better to protect the service with firewall rules and everything. Make sure that your bad clients can't get there, and then if nothing else, you can set this on top of that. But I wouldn't rely on this alone to protect the service. And also there's advanced options down here. So if you are familiar with Net-SNMP and you want to set up something like views or VACAM or whatever, you can dump that here in the custom options, and that'll pass through straight into SNMP, the SNMPD conf as is, exactly as you've got it formatted here. So up to you. Most people can just leave it blank though. All right, well, next we're going to flip over here to the host information tab. And the general info here is sort of like those free-form fields we had in BSNMPD. There's a couple more. You can set a location, a contact, a name for this firewall, which could be a fully qualified domain name or host name or a short name. I just put a short name here. And then a description, which is just a little bit longer text description. And those are all available through SNMP to where you can find, I can't remember if I'm trying to remember if I think it was, system description, but yeah, I guess it depends on the first one was from BSNMP. It filled it in with some uname information, and then this one here, it actually shows you the system description. So, and that again can be used by an NMS, especially for auto discovery or automatic population of data as it creates a profile for a device. Interface handling here can provide some tweaks to help with dynamic interfaces that appear and disappear. Mostly on pfSense, they're going to be fairly static, but there are some that come and go. TON interfaces and PPV interfaces can be created, destroyed, and they may come and go. If you find your interface indexes in SNMP are changing more than you expect, or they're unpredictable, you could set this to a higher value so that these entries are retained in the table longer than for a longer amount of time. And then that replace old interfaces also still keeps it stable, because if an interface goes away and comes back, if that's checked, it will just replace the old entry and it will just act like it was not really gone. If you take that out, when it comes back, it'll be added as another interface further along in the index tree. So if you're looking for stability in your indexes, which is good for an NMS, you want that you want replace old interfaces checked and the fade out set fairly high. 300 seconds is 5 minutes, so that's an okay thing, because most of the time if something's removed and comes back, it's going to be well under that, because it's probably like an interface getting recreated or applied when a daemon restarts. So that should be fairly safe. Disk handling, it's kind of a mixed bag. SNMP will set an error flag on its own when a disk usage on a given partition is below this value, but odds are if you're worried about disk usage, you're going to have your own thresholds and things set up in your NMS, so it's not that critical, but it's there if you want to set it. Same with load monitoring. You can do load average monitoring here, and it will set an LA error flag if any of them are above this value, but again, your NMS may have its own thresholds you can configure. And because there are 3 values for load monitoring, for example, if we're going to do an SNMP walk with LA error flag, you'll see there are 3. It's actually got 3 indexes under here. Like most things are single values, so you just access them with .0. But when something has multiple values, you'll access it by the index, which is 1, 2, 3. If you're not sure, instead of doing an SNMP get, do SNMP walk like I did here, and it will walk down a tree and find anything under there. So it's a little bit more forgiving if you're not exactly sure what you're looking for. Okay, and here are the extended commands, which we're going to spend some time talking about. These extended commands, they run a shell command, and it returns the output from that command by SNMP. So you can use it in combination with scripts or standalone programs to retrieve status values that are not directly available in SNMP. These entries are indexed by name rather than completely relying on an OID in a specific order. Like if you've used these before, or like the old exec commands in Net-SNMP, they had a really obscure OID that you had to go with, and they had to be in a certain order. And if you made a change or an edit, the order might shift, and it might mess up what you had in your NMS. But now these are all indexed by name, so it doesn't matter what order they're in. You find them by the name. You can do this ns-extend output 1 to get a list of all these. And it'll show you the output from all these different, that's like the error, the results, how many lines were in the result, and then there's output full, which has all it. So everything you'd want to see is going to be under that, and then you can actually drill down from there and get what you want. But if you're looking for you'd want like hold on, let me find it. Like one of these extend output full curse dates, for example. Like if you had that, some days I hate petty. See, that won't work, but you got to escape those quotes. There you go. So you can find it using, you can reference it using the single value by name with the ns-extend output full, and then dot, and then your escaped quotes, and then the name of your command and another escape quote. So all of these entries, they each have several fields here. First is that type field. It can be an extend or an extend fix. I'm only going to talk about extend today. Extend fix is a little bit more complicated, which you can trigger a command based on the state of something else. But for like if there's a problem, the extend fix command could automatically fix something ideally. But we won't get into that one today. It's a little bit more complicated. We're just going to talk about extend. You got MIB OID, which most people are going to leave this blank, but if you want to change the OID location where this command output will be rooted, you can do that, but it's still going to be indexed by name, so you can't define the complete OID for this as they're defined here. So it doesn't override that name indexing. It just changes the root of where everything starts. So again, most people are going to leave that blank, but it's there in case somebody wants it. Name is going to be the short name of your command used to retrieve the output. Like you can see here, I've got this one has curse states for the name, and that's how I accessed it using curse states. Next up is your program column, and this is the full path to a specific binary or script that will be called. You can't put arguments or anything else in here. The first parameter has to be the full path to an actual binary or script. And then your arguments go in the arguments column. Now, neither the program nor arguments column will allow you to do like pipes and redirects and things, so you have to put everything, your program in one, and then the arguments to that program in the other. If you need a complicated, like a shell pipe, 3 or 4 commands deep, whatever, you have to create a script with that, and then you can call the script from the extend command. And I'll show you how to do that next. So for this example, I was going to say retrieve your current pf state table usage. So I've got this one, it's set to extend, it's blank. I got curse states, which I showed you a moment ago. And then it's using this /root/snmp curse states.sh. And the contents of that script are right here, just 2 lines. It's got the shebang for bin.sh, and it's got this string of commands here, which looks at dumps some information from pfctl, then it greps for the state table info and grabs just the line with the number and then prints just the right parameter. And then make sure that script is executable, and then it will output the current value of the state table right there. Even though it says a string because that's what all the extends will return that, but your NMS should be able to interpret a value like that. Now I've got some crazier examples over here, like if I do like gateway status, I mean, it'll show me the full gateway status here. Now, obviously, that's not going to be something that an NMS is going to be able to interpret directly, because it's going to want some specific things formatted a specific way. Like you might have to write a script that takes that data and rigs it up in such a way that it just has something like your gateway name colon online offline or up down or true false, something like that. And then you may have to have some sort of a processing script in your NMS that interprets that in a special way. But again, all of that varies on your NMS and what it supports and how you can massage that data. But the extend commands will let you get that out of pfSense across the network, and then your NMS can do with it what it needs. Okay, so how do you get access to this stuff? Well, if you're going to use V1 or V2C, you're stuck using communities. So you can set up as many communities as you want over here. Just for an example here, I've got a public community and a public read-only community, and then a pfSense read-write community. But obviously you want to use stronger names for that. Click plus to add a new entry here, and then you've got several fields. You can put in your community name, which should be something, like I said, long, hopefully got some randomized component to it. You can have as many of these as you want, set up with different access controls. So you just need a way to keep those straight internally. You can change whether it gets read-only access or read-write. Now, for most everything an NMS is going to need to do, read-only is fine. There are some more advanced scenarios where you might want read-write, but for now, you just really want read-only. The address family sets up how this community can be accessed. By default, it's just IPv4. You could set up a community that does IPv4 only, IPv6 only, or both. Source restrictions let you set up, like it says, a network source restriction. So if you only want this community to be accessible from a certain site or a certain local management network, whatever, you can set up the source restriction here, either an IP address or a subnet. And that has to match the address family that you put above there. So if you want an IPv4 restriction, then you need a community entry for just IPv4. If you want an IPv6 restriction, then you need a V6 community. So if you're going to do both, I don't think it really would do a source restriction the right way. But yeah, if you can also set a base OID, which will limit access to this community to just a certain chunk of the SNMP data tree. So that's also a good way to set up a restriction. If you know somebody only needs access to a specific group of OIDs, like maybe you only want somebody to have access to the interface information, you could lock it down so their base OID is just like the interface table, and that's all they can see. And then further with the source restriction, you can set that up. If you don't want to, if you want to set an OID restriction but not a source restriction, you do have to put default in the source restriction. That way it can set up the right parameters. So communities are not great, but at least with us at Net-SNMP, we have a little bit more flexibility security-wise, saying, okay, yeah, I'm stuck using this community, but I could be strict about where this can come from and what it can see. It's not just, okay, here's your weak community name and you can just get everything. A little bit better. Over here are users. Now, users are only for SNMP v3, which if you use a user, it's going to automatically kick over to v3. By default, when you go to this users tab, you're going to have a manager user, and you're just going to want to leave that alone because that is used internally by SNMP for communicating back and forth with its own agent stuff. So it's just a user that it uses itself internally to communicate from itself to itself. It automatically generates a long randomized password that's unique for everybody when it's installed. So you don't really have to worry about the security of this user. It should be okay on its own. If you feel like you want to reset the password on that, you can set the password and passphrase to something you want, but the default's pretty long and random, so it's generally okay. But to make your own entry, just hit plus, and then let's do for USM, we're just going to talk about just a plain username and password. Just my user. If you're just using user auth, you can leave this on USM. If it was just a certificate mapping, which we'll talk about in a moment, you'd use that. Or if you want to do both, you can have it active for both. You can do both a user entry and a certificate mapping, which I like doing both. But again, if you're not using TLS, you don't have to worry about certificate mappings or TSM. You can just use a user entry. Description, this is just for your reference. I think it's just in the pfSense GUI. It doesn't get put through to the SNMP config, so it doesn't really matter. Read-write access, same with a community. You can set it for read-only or read-write. You can also set a base OID restriction so that they can only see part of the tree. Now here is the meat and potatoes of the USM stuff. You can set authentication type. This is how it hashes your password. It can either be SHA or MD5, preferably SHA. But not all software may support SHA. So again, you're stuck with whatever your NMS supports. And then your password. So like my password. And then your privacy protocol is going to be how the communication will be encrypted with this user. Now it's just some basic encryption here, nothing too fancy, just encrypted based on your passphrase. If your software doesn't support it, you can set it to none. If you do AES is the best one to use of the choices. DES is there. I wouldn't use it unless it's the only thing your software supports, but even then DES is pretty weak. Passphrase is just a random passphrase. It just needs to match whatever the client puts in their client. And then your minimum USM security level sets what they can do. Unauthenticated would let somebody in just by specifying that I'm this user, sort of like a community, which isn't that great. Authenticated makes sure that they have supplied their username and their password. And private makes sure that they have specified the username, the password, and that the encryption is active. So ideally, in a perfect world, you'd use private and everything would be good. But if you want encryption to be optional for that user, you can set it to authenticated. I wouldn't go any lower than authenticated, but again, entirely up to you. And that's just all what I was just telling you there. Make sure I didn't skip anything. Oh, the password must be a minimum of 8 characters or longer. Longer the better, but minimum of 8. Yeah, okay. So moving on, the last part here is our Net-SNMP TLS here, the certificate mappings. If you're going to use that, remember your user has to be set as to an entry type of a certificate mapping or both. And then the priority isn't really that important. That would be if you had multiple mappings set up for the same user to check different fields of their certificate. We're not really going to do that. Most people don't have to, since one user, you're just going to have their certificate set up the way you want it. You don't need to have multiple ones and all kinds of crazy stuff trying to match them. So I just put a default priority of 10 in there, just leave it alone. And then you pick your user certificate, which has to be imported into the certificate manager. And then the certificate field here, there are several choices. It defines which field of the certificate will match the username. So my username in this case is my user. Now this particular certificate doesn't have my user in it anywhere, but ideally, if your common name of the certificate matches the username, like if I had a certificate where the common name was my username is my user, that's what I'd pick. You can enter a manual security name, like I could manually enter my user to override that, but it's best to have a field in the certificate match. So you can also match based on a subject alternative name of whether it's an email address or a host name or a fully qualified domain name or an IP address or your common name. Or you can match any SAN value. It'll go through and search them all for something that matches up. So those are all the different ways you can pair up a certificate with a user. Now security name here, you leave that blank unless you actually entered the manual security name, which that's all fine. And then again, you've got your minimum security level, which ideally leave it at private. If you're doing TLS, you got certificate, it's going to be encrypted anyway, so there's no reason to use anything lower with TSM. All right, so that's it. I do have a little bit of extra time here. Let me go through. I want to show you how this particular, how an MIB gets translated into an OID. So you kind of have to go a little bit forwards and backwards. I started this file here from the top down, but to find all of this, I kind of had to go from the bottom up. So I wanted to look at the pfMIB here. And in order to find out where this is rooted, like see, all I see here is the 200 and then Bergamot. So I had to go back from here to find where it imported this Bergamot from. And then I had to go here and see it imports focus. So I had to go back to focus. And then I got here and I thought, okay, it imports enterprises from SNMP to SMI. So I found out finally where the root of it all, where I had to start. And so you kind of have to follow down. This is under enterprises. So enterprises was private 1, then private was internet 4, DoD, and internet was DoD 1, DoD is org 6, and org is ISO 3. So that kind of builds it all the way back from the bottom. So the starting value is always 1 dot. Anything that's assigned by ISO is under 1 dot. So you have enterprises, which is 1 dot, 3 for org, 6 for DoD, 1 for internet, 4 for private, 1 for enterprise. So 136141. And then underneath there, we got to the focus stuff, which was enterprises 12325. So now we're up to 136141, 12325. Under there, we got to Bergamot, which was focus.1. And then under there, for PF was Bergamot.200 or Bergamot 200. So now we've got all of these. And then PF objects, again, was Bergamot PF1. And then PF status was Bergamot PF objects 1. And so finally, we've got to PF status running, which was again PF status.1. So the result for this is 136.141.12325.200.1.1.1. And now, since those values are indexed by an instance ID, you almost always add another 0 afterwards for a single object. But if there's multiple, like I showed you with the LA error flag, there might be, it might be an index starting with 1. When in doubt, do an SNMP walk at the 1 level down, and you'll find it. So if we look at this, and here's the command I was using, SNMP get -m, and then I added the MIB dir, and then V2C public. This was against BSNMPD, by the way, because it had to be for PF. And then I used the namespace identifier here with PF status running, which is Bergamot PF MIB : PF status running .0. And then I got the integer back. Now, I could have left off this part because the PF status running is unique. So if I go back to right here and I just do PF status running. Now because I did, now I got to do the -m. And let's see what I messed up there. /user/share/ Oh, well, no. Well, maybe that did need the whole thing there. Okay, well, I guess that one did need it. But usually you can leave that off. But in this case, I had to specify it. Let's see. So I got that. In just a few different ways you can show this notation. When I was doing this, that was just the standard one with where it outputs the name. If you do capital O little u, it'll output the UCD format, which says enterprises. It actually shows you the structure of how it got there. Then you can break down enterprise further, so it's ISO, org, DoD, internet, private enterprises. So it could end up for a really long string, but almost nothing can reference this the other way, so it's not really useful except if you're trying to track down where it is among all of the MIBs. And then you can also use dash capital O small n to have it print out the OID so you could find that. Because if your NMS can't import MIBs for some reason, or if you have to put in the numerical OID, then you can find it that way. Just do an SNMP getter walk with dash capital O lowercase n, and then on what you're trying to find, and it'll output it. And you can also see too up here where it shows your definition for this particular object, it's set for a truth value. So, if it's 1, it's going to be true. If it's 0, it's false. So down here, because it has access to the MIB, it was able to actually interpret that as true, not just an integer of 1. There you go. So that's how it works, how you get from an MIB name all the way down to an OID. But all right, so that's it for today. I don't know if anybody had any questions. I didn't really didn't show any of the actual NMS software because I didn't have any demo stuff set up, and it was a lot of them are fairly complicated to get going, and I was running a little short on time. But I didn't want to have to demo something else because odds are it's not going to be what people are using. But pretty common stuff out there. There's tons of things, and they all support different stuff. So you're pretty well set if you want to fire up something like Cacti or Zabbix or whatever. But some of those things too have their own agents. So you may not actually need SNMP to get data from some of them, but SNMP is a good general thing that pretty much everything will support. Okay, any questions? You can type something in the chat if you need to say something. Otherwise, may have to call it done. Okay, well, I guess there's no questions this month. So thank everybody for attending. Have a nice weekend, a holiday weekend for most, and we'll see you back here next month.